All right, hello. Today we are continuing with working with division, and we are going to start dividing 3-digit numbers. Yesterday we talked about, let's just flip the page back. We talked about breaking apart the section of road into 600 equal sections 5 times to give us our 3,000 miles. So we're going to do something very similar to that today. And I told you that we'd talk a little bit more about that vocabulary. I have posted this onto our Schoology math page, and you can refer to it anytime you need to. There are 3 different ways that you will see division. The first way is in a straight line like this. Our dividend is our biggest number, and we have divided by our divisor equals the quotient. The quotient is the answer. You could also see division like this. Okay? Our dividend, our biggest number, goes on the inside, and our divisor goes on the outside, and then the quotient, the answer, goes on top. And the third way that you could see division is like this. We would say this is 20 divided by, when we see the line, divided by 4. Dividend divided by divisor equals our quotient, which is 5. And when we come back to school, I'll have this hanging up in the room too, so we can use it. This also gives us a little heads up to what we're going to be doing in the future in 4th grade, because this looks an awful lot like fractions. Okay, so when you see that line for fractions, remember it means to divide. All right, so there's our vocabulary page, and let's go ahead and get started with our question. There are 150 students going on a field trip. Students are put into equal groups of 6. How many groups are there? Are there any students left over? So we can show this by drawing a model. We have our rectangle here with 150 total people and 6 groups of how many people. So right here they wrote the equation for us, 150 divided by 6, and we're going to look to see how they broke this down for us. They went, oh, look at that, there's that expanded form. 20 plus 5 equals 25. That's the answer that they're giving us ahead of time. What we're interested in is how they got this answer. So they said, we know division is the opposite of multiplication. So 6 times what number will get me close to 150? 6 times 20, I know because I know my basic math facts. 6 times 2 is 12 with 0 on the end is 120. And if I have 150, I can take 120 away. So I know that I can fit at least 20 people in that group. So how much is left over after we account for those people? We take away the 120 people that we've already accounted for, and we're left with 30 more people. Well, now we're thinking, well, I can take those 30 people and start putting them in groups too. How many more groups can I make? Well, we know that 6 times 5 is 30. 6 times 5 is 30. So 30 minus 30 is 0. If I have 0 people left over, that means there are no students left over. There is no remainder because I have 0. And when I add these together, I get 25 different groups. We can use multiplication to check our answer. 6 times 20 is 120. 5 times 6 is 30. When we add that together, we get our total, which is 150. So there are 25 groups and 0 students left over. Now I know that seems like a lot, but we're going to continue to work with this. I want you guys to understand what it means to divide these 150 students into different groups. Okay? At the bottom of page 124, they are saying we can also subtract the partial products to divide the numbers. So here, they took 150 and they're like, well, I know 6 times 20 is 120. My leftover is still 30. 6 times 5 is 30 with 0 remainder. So they're subtracting these partial products in order to find the answer for the division problem. Stop subtracting when you reach 0 or a number less than the divisor, which is 6. So if we had 4 people left over, we couldn't make another group because a group has to have 6. So we would have to say there were 4 students left over. The quotient is the sum of all the numbers you multiplied by 6. 20 plus 5 equals 25. There are 25 groups and 0 students left over. All right, let's work together through some of these questions on page 125. Make sure I get the page. I can't see with my new setup here, so. All right. Melinda decided to split her area model into 5 sections that each show 6 times 5 equals 30. Draw Melinda's area model below. Then show how to subtract the partial products to find the answer. All right, what is this question wanting me to do? She split an area model into 5 sections. So I'm going to draw my area model and split it into 5 sections. 1, 2, 3, 4. That makes 5. 1, 2, 3, 4, 5. So she split her 5 sections that each show 6 times 5. So each section she's saying 6 times 5 equals 30. Draw Melinda's area model below. Check, we did that. Then show how to subtract the partial products to find the answer. So they want us to use these numbers to show this. So we have 150 total, and we have 5 different sections that each show 30. So if I have 150 total and I subtract 30, I'm left with 120. So if I take 120 and subtract that 30 again, I'm left with 90. And I'm going to keep subtracting my partial products. So, then show how to subtract the partial products to find the answer. Well, I got 0 remainder, no remainder. Can you use Melinda's model to solve the problem? Why or why not? Well, we had 5 different sections. Let's think about that. If this whole rectangle is 150, we show that we can add, if we add these 5 sections together each time, 30 plus 30 plus 30, let's see, 30, 60, 90, 120, 150. So yes, we can, if we do the reverse and we add the 5 sections, we get 150. Explain how an area model can help you break apart. Explain how an area model can help you break apart a division problem to make it easier to solve. So if we break it into sections, we can subtract our partial product each time. So by repeated subtraction, and smaller multiplication problems, help make division easier. All right, now here comes the test, the try it, to see if we can do this when we're given a problem. So we're gonna do number 5 together, and we'll probably do number 6 together too, because I want to slow down a little bit on this lesson so we can have some practice in dividing. So number 5 is 132 divided by 3. Okay. I'm going to move this up here so that you can still see it. Now, I'm going to think about the number 3. If I draw an area model, just to help me picture it, I have 132. That's what the largest number, that dividend is. And my divisor is the number that I'm dividing it by. So I need to figure out this right here. My, the quotient, the answer for 132 divided by 3. I am going to use multiplication to help me solve this problem. If I can do, how many times, I love multiplying by tens, let's be honest. It's easy once you know what you're doing. 30 times 10, if I did that, I would get 30. And I know there's at least 30 pieces in here, right? We have 132 pieces of chocolate. And I know that I can at least have 10 groups of that if I'm putting them into groups of 3. But, okay, here's the thing with division. You can take however many you want out of it every time. So if we take 132 and I say, I'm just going to skip straight to this because I think it's the easiest way to see it. 132. I know that I can fit, if I do 3 times 10, I can take that away because I have 30 in this, in my big number. So if I see what I have left over, I have 102 left over. Now I could do that again. Take 10 away. Now, I could borrow, or I could say, what's 10 minus 3? Okay, do you guys see that? 10 minus 3, instead of doing that, 10 minus 3, it's the same thing. Okay, now I have 72 left. Can I do 10 again? 10 times 3, I can take 30 away again. Can I do it again? Absolutely. Could I take 10 away? Could I do 10 times 3 again? Can I take 30 away from 12? No. If I only have 12 left and I need, my other number is 3, I'm thinking of my fact families right away. And I know that 3 times 4 is 12. So that leaves me with 0. This tells me 0 is my remainder. So I have no remainder, but I'm trying to figure out what my answer is. And I've done all this repeated subtraction. On this side, I'm going to add these numbers up to see what my quotient is. 10, 20, 30, 44. So our quotient is 44. Now, there is a traditional way to do division, and I'm not going to get into that yet because I want you to be able to know that when you break apart these numbers, you can do that repeated subtraction. It doesn't matter. With the traditional way, you have to get the right answer the first time. With the repeated subtraction, you can take away whatever number feels comfortable to you. So, I'm going to do the exact same problem again. And let's say, 3 times 3 is 9. And if you put a 0 on it, it's 90. So 3 times 30 is 90. So right away, you can, instead of subtracting 30 every time, right away, you're subtracting 90. So 13 minus 9. You guys see how I did that? Now, I'm thinking, well, look at that. Now I can take 30 out. Because 3 times 10 is 30. And it leaves me with that 12. And I know that 3 times 4 is 12. So I have no remainder. And then I add this side up. 30, 44. So I can get the same answer in fewer steps because I kind of went ahead and I subtracted more all at once. So with this way, it doesn't matter how many times you have to break the number apart, you could still get the right answer. All right, let's try another one. Number 6. We have 364 divided by 7. When I set the problem up, my larger number always goes inside, and we like to call this strategy, the book will call it using like partial products, but if we want, what we did last year was we called it hangman division, because it looks like you're setting up to play hangman on a hangman board. So we call this hangman division, and it's not your traditional way, but it might be easier for some of you if you give it a try. So I'm thinking, how many times can 7 go into 364? If you love tens as much as I do, put a 10 in there. So 10 times 7 is 70. So you're automatically taking 10 away every time. You don't have to do 10 though. What if I was like, well, I like 7 times 5 because I like 5s, but I'm not going to take away just 35. I am going to do 7 times 50. 7 times 50, and we should be able to do that because we know 7 times 5 is 35 plus our 0 on the end, because we know how to multiply those big numbers now, right? 7 times 50 is 350. Can I take away 350 from 364? Yeah, because as long as your top number is bigger, you can do that subtraction problem. So 14, look at that. So by doing that number first, I skipped a lot of steps. If I would have done 10, I would have had to do 10, 10, 10, 10, 10, 10. So try to get it close. Now, 7 times what number gives me 14? 7 times 2 gives me 14, which means I have 0 as a remainder and 52 as my quotient. Again, doesn't matter how many times or what number you're doing here, as long as you can subtract it from the number that you have, you will get the correct answer. We are going to practice how to do the subtraction. If you need more help and you want a one-on-one session, let me know and we'll meet on Teams and we can do some practicing together.